On July 30th, 2025, the USGS issued a rare red alert, not for one volcano, but for the entire Cascade Range. For the first time, Mount Rainier, Mount St. Helens, and Mount Hood are under a single urgent warning. The reason? Scientists have discovered vast magma tunnels connecting these three giants deep underground. This changes everything. What was once thought to be three separate threats is now a single, unpredictable system. The red alert means an eruption at one could trigger activity in the others. Millions in the Pacific Northwest are now facing a new kind of volcanic risk, one that's networked, volatile, and poorly understood. Advanced satellite data revealed these tunnels, forcing a total re-evaluation of volcanic hazards. Emergency agencies are on high alert, and the public is urged to prepare for scenarios never before considered. The question is no longer if one volcano will erupt, but what happens if the whole system is set in motion. This is not a drill. It's a fundamental shift in our understanding of the Cascades. The red alert is a call to action for scientists, officials, and everyone living in the shadow of these mountains. The story of this discovery is a testament to the power of modern technology and a warning of nature's unpredictability. The stakes have never been higher. Imagine the Earth's crust as a vast hidden plumbing system. Magma, stored miles below, usually feeds each volcano through its own chamber. But now, we know these volcanoes share a network of deep tunnels, massive conduits that let magma and pressure move between them. These aren't empty caves, but pressurized pathways carved by molten rock over millions of years. If pressure builds in one, it can surge through the tunnels, destabilizing the others, like squeezing one water balloon and watching the rest bulge. This interconnected system means a disturbance at Mount Hood could trigger unrest at Rainier or St. Helens, and vice versa. The discovery of these tunnels is what makes this red alert so urgent. Scientists now face a new, unpredictable threat, a superhighway for volcanic energy beneath the Pacific Northwest. The risk isn't just eruption, it's the unknown ways these giants can now influence each other. This revelation didn't come from digging or hiking, it came from space. Using advanced satellites equipped with INSAR, scientists detected subtle ground swelling not just at one volcano, but along a line connecting all three. Gravity anomaly detectors confirmed a dense mass deep below, matching the uplift. The data revealed a continuous 150-mile-long bulge, evidence of a massive active magma conduit. Overlaying satellite images and gravity maps, the connection was undeniable. Traditional sensors missed it, but this new technology let us see the hidden network for the first time. The result? A clear, alarming picture of a system that's far more complex than anyone imagined. This breakthrough has rewritten the playbook for monitoring and understanding volcanic threats. The Cascades are no longer isolated peaks, they're a single dynamic system. And now, the world is watching. Each of these volcanoes is dangerous on its own. Mount Rainier, towering over Seattle, is infamous for deadly lahars, mudflows that can reach cities in under an hour. Mount St. Helens' 1980 eruption was a national wake-up call, proving how explosive the Cascades can be. St. Helens is the most active, rebuilding and erupting repeatedly. Mount Hood, looming over Portland, hasn't erupted in centuries but remains restless, with glaciers that could unleash devastating mudflows. Until now, emergency plans assumed only one would erupt at a time. The discovery of their underground link changes everything. Rainier's lahars, St. Helens blasts, and Hood's proximity to Portland are now part of a single, unpredictable puzzle. The risk isn't just multiplied, it's transformed. Planners must now prepare for scenarios where multiple giants awaken together. The stakes for the Pacific Northwest have never been higher. The old rules no longer apply. Scientists are alarmed because the rules of volcanic forecasting have changed overnight. Pressure changes that trigger eruptions might now come from far away, not just beneath a single volcano. A magma surge under Mount Hood could set off Rainier or St. Helens, making prediction far more complex. The shared tunnel system means a much larger reservoir of magma could be tapped, fueling bigger, longer eruptions. Hazard maps and emergency plans, built for single eruptions, are suddenly outdated. The possibility of simultaneous or rapid-fire eruptions is now real. The entire region must rethink what volcanic risk means. The most frightening scenario is a domino effect, one eruption triggering another. A blast at St. Helens could depressurize the tunnels, sending magma surging toward Rainier and Hood. This could cause explosive eruptions at all three, turning a local disaster into a regional catastrophe. Emergency services would be overwhelmed, and millions could be affected by ash, lahars, and air travel shutdowns. Even a single eruption could last much longer, fed by the network, like Iceland's Loki eruption, which lasted months. The mixing of different magmas could make eruptions more violent than history suggests. Rainier, usually known for mudflows, could unleash a blast rivaling St. Helens. The tunnels have created a new level of explosive potential. The Pacific Northwest faces a threat unlike anything in its past. Preparation is now more urgent than ever. Experts urge calm, but also preparation. The USGS is ramping up monitoring, deploying more sensors and satellites to track magma movement along the entire tunnel system. Residents are advised to be 2 weeks ready, with supplies, evacuation plans, and go bags. Emergency agencies are updating hazard maps and response strategies for this new, interconnected threat. Public information campaigns will help everyone understand the risks and what to do if an alert is issued. This discovery is a humbling reminder of nature's power and our need to adapt. The coming months will bring intense research and public education. By respecting the science and preparing wisely, we can face the future in the shadow of these newly connected giants.